Good afternoon, good evening to everybody here. With me, I have Wayne Eckerson from the Eckerson Group. Wayne, super excited to have you here.
Yeah, great to be here.
Before we get started, do you have some sort of a fire going on behind you? This is supposed to be a fireside chat.
I wasn't able to put my green screen up in time.
I at least wore my sweater to keep me warm. So very excited to be talking with you over here, Wayne. For those who don't know, Wayne Eckerson is an international thought leader in data and analytics, who thinks critically, writes clearly, and presents persuasively about complex topics. He's a best-selling author, sought-after consultant, and a noted speaker. Wayne has advised a range of companies about how to implement data analytics programs, architectures, all the way from infrastructure to the applications, including some big companies like Walmart, New Balance, and the Children's Hospital of Philadelphia. Wayne's the president of the Eckerson Group, a consulting and research firms that helps organizations get more value out of their data. And Wayne obviously has been researching DataOps for a few years now. And, I'm very excited because you have that perspective of working with thousands of companies, some Fortune 100 companies as well, and really helping them shape their data roadmap, as well as, you've been in their journey as they have been implementing all of these data practices in their businesses as well. So I'm sure all of us are excited to hear your perspective and all the knowledge that you've gathered over the years around DataOps. So first question really, Wayne, before we jump into, what is DataOps and how can one get started, I would love to understand your perspective on what are some key challenges that these businesses face, what slows them down, and, what is keeping these data teams up at night, and what are they really trying to do, to unblock some of these challenges?
Yeah, I think if you boil it all down, the key challenge is that there's too much demand and too little supply. So, as data has proliferated and the number and variety of sources and types of data have changed, and as companies have gotten used to using data to make decisions, there's just a growing demand for data throughout. Yet at the same time, the complexity of building data pipelines, which is the process of moving data from one or more sources to a target, has just gotten much more complex. And that requires skilled people, data engineers, very skilled data analysts, and there's just not enough of those folks. And you wrap all that together and you create this huge data bottleneck. So that's a huge problem. And from a business perspective, they don't like to wait, and we're forcing them to wait. And oftentimes, because of the complexity, we're delivering solutions with too many defects at high cost, and that's just a recipe for very disappointed customers. So it's the opposite of what I think is our goal, which is faster, better, cheaper, and we're delivering slower, more costly, and less quality. So we've got some work to do.
And Wayne, with these challenges, how do people think about unblocking them? What is the antidote here?
Yeah, I see companies taking two approaches. One is, well, if we don't have enough data engineers, let's implement self-service, so that regular business people can get their own data, and that's valid and valuable. The other approach is, let's make the data teams much more productive, and really that's what DataOps is all about. And it's about taking our data teams, development teams, giving them the tools and the processes and the mindset, most importantly, to deliver code faster with fewer defects, foster greater code reuse to generate more efficiency and agility. So scaling our team-based development with DataOps. And I truly believe that DataOps is the thing we've been looking for all these years. It's the missing ingredient to help us deliver faster, better, cheaper, and create happier customers.
You're absolutely right. We deal with hundreds of companies that talk again about all this complexity, and everybody wants to create value out of their data sets, and companies are gathering more data than they ever have before. And I think what's important is it's no longer a science project, right? This is becoming mainstream. This is what the business is running on. In fact, every company is turning into a data company. So, how does someone go from, I think you said it perfectly, from doing it in an artisanal way to having an industrializational approach to making this process more repeatable? And I think, would love to hear from you around what is DataOps at the end of the day? What does it hope to achieve? And what are the key pillars that people should be looking to when they're trying to implement DataOps in their own practices?
Yeah, it's a good question, because there's a lot of confusion around DataOps, which is short for data operations. And to be truthful, it's a very big tent. But basically, we can define it as the process and the tools to optimize the development and execution of data pipelines, getting data from source to target and do all the transformations needed to create happy customers. And you mentioned this artisanal to industrial evolution. For the past 20, 30 years since we've been doing business intelligence and analytics, it's always been done by a lone wolf, doing things on their own, coding things on their own. And when they leave the company, they take all the knowledge with them. So DataOps helps us move from a lone wolf artisanal approach to data pipeline development to an industrial approach where we have teams and developers working on teams in parallel to build robust sets of code quickly with few defects for customers. And it's a big tent, as I said. It's got a lot of dimensions. It kind of pulls in a number of different disciplines, which you see here. There's Agile component of it. There's DevOps, which DataOps is a takeoff on that. There's also total quality management, and even Lean is mixed into this brew, which we call DataOps. And so depending who you talk to, they're going to emphasize one thing over another. Like for some people, DataOps is about cross-functional, cross-trained SWAT teams. For someone else, it's about CI/CD, continuous integration, continuous development, and DevOps and Git repositories. For others, it might be test-driven development and monitoring, playing off the TQM angle. And for others, it might be automation and orchestration, playing off the Lean dimension. So different vendors, different vendors emphasize different things typically, and then different organizations that have implemented DataOps are kind of starting in one place and then moving about as they mature and evolve in their capabilities. So I'm wondering if that's kind of what you're seeing. This is a
very interesting chart here. Yeah, no, this is a very interesting chart here. Would love to actually double click on these 4 dimensions that you have put out here, right? Could you walk us through, the agility aspect, the DevOps aspect, the TQM and the Lean aspect in a little bit more detail? Because all of us here who are attending this conference are trying to implement DataOps within our own businesses. So what are some key elements in each of these different dimensions?
Yeah, so I come out of the business intelligence space. So when you talk to BI and data warehousing folks, you say DataOps, they tend to think about Agile, Scrum, and self-organizing teams that work hand in hand with subject matter experts in short sprints to develop working code that's tested. And then the thing I like about Agile is that at the end of each sprint, you have a retrospective or a debriefing where you talk about what went well and what didn't work well, and you work to improve it. And in fact, to me, that retrospective or the debriefing is really the heart and soul of DataOps, which I will talk about this next, which is continuous improvement. Ultimately, that's what we're trying to do.
Yeah.
DevOps, I think, is probably the discipline that's taking the most root in this space, and because it's got the most tools. GitHub is a place where, DevOps came out of the software engineering space, and they've developed tools like code repositories like Git, CI/CD tools to foster team-based development. And those have been so successful in the software engineering space that a lot of companies are just borrowing those tools and concepts wholesale and bringing them into the world of data. Now, of course, data is a little bit more complex than software engineering because we not only have software code, but we also have data. And so how do you manage data like you do code? And I think that's something we're still wrapping our minds around in our space. TQM, total quality management, is all about continuous measurement, monitoring, benchmarking, continuous improvement. Again, it's all about having metrics that you hold yourself accountable for. We can even throw continuous testing in there or test-driven development, which also is in the DevOps space. And then Lean is all about automation, right? And identifying waste and extra steps and trying to simplify and standardize your processes. And ultimately, data pipelines are extremely complex, and whatever we can do to simplify them is great, because then we can automate them much easier. So a lot of companies in this space talk about design patterns, right? So we're going to develop a design pattern to do this piece of thing, like ingest code from NoSQL databases, and we're going to create that pattern once, and then whenever we need to access that type of system, we'll use this pattern and these tools and this process to ingest that data, and we'll do it the same way every single time. So that's an example of applying lean thinking to the data world, and I think that's, again, part of this whole DataOps approach to data pipeline development and execution.
Yeah, Wayne, I think that data pipeline part that you spoke about, I think that's super important to have that collaboration between everybody. There may be different people who are responsible for different portions of that end-to-end data app. There may be a person that's thinking about bringing all the data sets in. Another team member where she's thinking about transformations and connecting all of those different data sources together, and then presenting it to a data analyst or a data scientist who may then be consuming that data for their own different use cases. What we have seen as people are moving away from thinking about these data applications in a waterfall methodology to truly having this continuous improvement and continuous feedback loop into that methodology these days. This is great. So could you help us walk through how the team members are organized around these, and what are these different stages that you're traditionally seeing data teams actually adopt in their data ops practice now?
Yeah. So what's interesting, and I didn't realize this until after I put these slides together, was that these disciplines that I'm showing on this slide, they're very distinct, right? And they're separated by a white line, but really they're all part of the same continuous process or loop, which you've created. And this is from you guys, and I love it because it shows how all those things we just talked about are actually integral. They're part of a continuous loop that connects development and operations inside the technical teams, but also, as you show here, connects the technical teams and technical users with the business people who are the consumers of the product that you're building with this technology. So you can start on the left-hand side with the create, right? That's kind of the starting point. You create, you build, And once you build, you put into production, you orchestrate, you come back to the drawing board, you test and fix. And then the right side is really more, I guess, the operational side. So you deploy, you operate, monitor, optimize, you get feedback, and then you do it all again, right? So the way to connect, the development side with the operations side and the technical side with the business side in a continuous iterative loop.
Wayne, who does what here? What are you traditionally seeing in terms of how these roles are now evolving and who's doing what? What is the role of a data engineer? We're also seeing the evolution of full stack data engineers or full stack data scientists these days versus what's the role of a platform engineer or what's the role of an operations person. What are you seeing out there with all of the companies that you're talking with?
Yeah, well, that's a good question. So, ultimately a data engineer is the person who creates and designs the data pipelines. But as we said at the outset, that they're in scarce supply, they're expensive. So ideally, we make tools easy enough so that data scientists and data analysts who are working on behalf of business users to solve problems can build a lot of the pipelines themselves. Maybe not the most complex ones, but maybe the simpler ones, especially if the data engineers put things in place to support self-service. And you mentioned the platform engineer. Well, they play a huge role, I think, as well, because if you have a really good platform or platform engineer to create a platform or enhance an existing one, you can build self-service into the platform to more burden off of the data engineer and enable data scientists and data analysts to do more of the data creation and delivery without having to enlist a data engineer. So then on the operations side, which we have up in the upper right here, those folks are there to monitor the process once something's been created or changed and then put into production. Their job is to really make sure that it runs properly. They're the ones who get paged in the middle of the night if something breaks, right? But that's not a sustainable way of life, or a great way to run a business is to have things break and then basically have your customers debug your product for you. So with DataOps, where the role of the operations admin changes from fixing things to more of preventing things through this whole DataOps concept.
We had another question here is, how are these teams now organized? Are they organized by a use case, right? Because in the early years, we used to see companies spinning up a large centralized cluster, right? And they would give it out to every tenant in their data team to go and hit that same system. What we're now starting to see is teams are getting more fragmented, where they may have several clusters in a company, and the clusters are all spun up by maybe a product group or a marketing group or a finance group for their own different use cases. Is there a certain trend that you're seeing in how these data teams and these data stacks are getting organized these days?
That's a really interesting question. It makes me think really hard. Because, back in the early days of data warehousing, the goal wasn't to build a data warehouse. It was actually to build subject-specific data marts to support individual departments. So they had a data set that was tailored to their needs, and all they had to do was go query it. But then we always had data analysts who bumped up against the edge of those data marts pretty quickly, or the semantic layers that were built in the BI tool, which served the same purpose. And so then we wanted to make the whole data warehouse available to those folks. And of course, before long, they bumped up against the boundaries of that and wanted even more. And then we gave them the data lake, right? And these were a lot of times data scientists, real power users who wanted all the raw data and then some, even external data. They didn't want anybody to pre-aggregate the data or model it. They just wanted it raw. clean but raw. And so that's where this whole big data came from, the data lake came from. But then that's just this unvarnished mass of data. And I think people realize that, geez, that really only services like 1 or 2% of the people in your organization. And we need to better differentiate that data in the data lake. So we're moving back into the realm of, okay, let's model the data a little bit. Let's create departmental views, which we can do now with cloud-based data warehouses. So we have the same data running in a data lake, maybe an object store, but now we can, using the separation of storage and compute, build out all these high-performing views on top of that without actually ever replicating or changing the data. So in many ways, we're using new technology to replicate what we were trying to build back in the 90s and the aughts, giving users, kind of a playground that's very much tailored to their needs, so they can be more efficient in conversing with data.
Everything comes back full circle, just like this loop here, it seems.
Really does. There's nothing new under the sun, just new ways of describing it.
Exactly. And I think, and that's why what we're seeing too is these use cases now have their own teams. They have their own architect, their own data engineer, in these nuclear teams, which is self-sufficient to be able to do this end-to-end. We had Cox Automotive speak earlier today, and they mentioned they have a team of 8 people. That's it, who do everything from development to deploying, managing, and running and scaling these applications as the business demands. Wayne, one more question before we move off this topic. Does anything over here become simpler or more complicated with the cloud?
I think it becomes a lot more simple. In fact, I was talking to the inventor of the Data Vault just today, and he's like, we don't need to model data using Data Vault anymore, even though a lot of companies have done that, because the new technology, the new cloud data platforms have made it not necessary to model your data for performance, because there's enough performance in the underlying technology, due to the separation of storage and compute. And then we can, create all these virtual views much more quickly. So not surprisingly, Cox Automotive can have 8 engineers supporting, I assume, the whole organization, creating those unique views for every business unit and department. So, the cloud, I think, has changed everything. And yeah, it's revolutionary what, new products that we're seeing on the market have done to this whole pipeline process, in accelerating it, helping us tailor it without creating huge costs and backlogs. So I think the combination of the methodology, which is DataOps, and the new cloud-based technologies are really, helping us cut through that Gordian knot of backlog that we've always been afflicted with.
Awesome. Wait, I'm sure everybody wants to listen to your advice on what are some practical things people can do to start the DataOps practice in their own businesses.
Yeah, good question. I get that a lot. The first is really to educate your team about the principles and concepts of DataOps. But the first real action-oriented step you can take is to get that team together and say, hey, what are our major bottlenecks? What's holding us back? Whether it's people or lack thereof, lack of the right skills, processes that need to be re-engineered, or lack of technology. What are the bottlenecks, and then how can we break through them? How can we optimize the people, process, and technology to go faster with less people and do it better along the way? And I think a key to that, as I mentioned earlier, was to take time out and debrief. And this sometimes takes a lot of courage. There was one organization we talked to that actually spent every 4th sprint doing a retrospective, not just the half day at the end of the sprint, the entire sprint, reviewing what they've done and figuring out ways to do it faster, better, cheaper. So, you have to sometimes take a step back to go 2 steps forward. And that, I think, is in many ways the heart of DataOps. And then monitor your improvement. And as I said earlier, I think DataOps really is a state of mind. It's about continuous improvement and spending the time, taking the time to really assess what you've done and figure out ways to do it better and do it. On the technical side, we should all be striving to componentize our code, moving in the direction of microservices, simplifying that code, and then most importantly, build tests for every code block. Tests on the input, tests on the output. I've asked people, what's the rule of thumb for how many tests you should build? Is it 4 tests for every code block? Well, it really varies based on the code and what you're trying to accomplish. But the more tests, the better. And then run those tests in production. That's going to save your operational admin a lot of headaches. Now, the third bullet here is to treat data as code. And, this is really hard to do before these cloud data platforms. It was hard to create snapshots. It was costly to replicate data, copy it, move it. So we didn't. We took samples or old data, and that's not ideal. But it's also impossible to put all your data in Git, right? So, the new cloud databases, take Snowflake, for example, with its zero copy clone and its time traveling, makes it actually possible to start treating data as code and creating snapshots from production data to support your dev and test. So they're not second-class citizens anymore. And then finally, invest in tools. I mean, everyone wants to put the tools first and foremost. I think those, that's having the tail wag the dog. I think you want the tools after you know what you're trying to accomplish and where you need to go. So you probably want a code repository, configuration repository, CI/CD tools, test management framework, strong orchestration that works with any type of tool, and a good monitoring framework so that you can automate your processes. So this is what we typically recommend to organizations that want to get started with DataOps. And I'm curious if this aligns with what you recommend.
Absolutely, Wayne. It like the statement that you make there, which is DataOps is a state of mind. It's a cultural shift, really. It is. You've got to organize your teams around having and being open to continuous feedback and improvement at the end of the day, and learning as we go along, because this is a new sport, and we don't know what we don't know just yet, and it's evolving, and we still have to run fast. So the feedback and the improvement piece is definitely the most important part. We may have time for one question here, Wayne. We've got Ravi here who's asking, how does version control play a role in DataOps? Would the data pipelines be version controlled, for example? Is the use case to version the actual data popular as well?
Yes, we want to version the code. That's what Git is for. And then the CI/CD makes sure that if you've got multiple developers working on the same code block, that they don't interfere with each other or write over each other. And if they do, you can resolve it very quickly. And we do want to do the same with data. And we want, as I said here, we want to treat data as a code and version that as well. And that's where the zero copy clone comes in, and time travel. So we can keep track of those versions and go back to them anytime we want. So I'm looking forward to other database vendors beginning to support those features, because that will really enable us to do better versioning of the data and support it as a full player in this DataOps process.
That's great, Wayne. I think we have time for one last question here with Craig, who says, I've seen a fully mature DataOps lifecycle, but not much on the maturity curve required to achieve this framework, do you have any thoughts or resources on how organizations should mature into this model? For example, should we focus on CI/CD, monitoring first, and QC, Agile, etc.? What are the different stages? Looks like this is a new piece of research that's being suggested to you, Wayne.
Well, everyone wants to dive in and buy tools, which I think you need tools, but the place you got to start. And I'm a consultant, so we advise companies all the time is understand where you're going, or you'll never get there. So if you sit down with your team and have a discussion to identify and prioritize your bottlenecks, that will dictate what you do, where you go, what tools you need to buy. I would start there, because you may find that the thing you need to do first is form cross-functional agile teams and nail that. Start getting more interactive discussions with your business people, and that doesn't require tools at all. But then again, maybe you'll find that you've got too many defects, and so you really need to put in more tests. So you might want to invest in a test management framework. Now, the fortunate thing is that there's, this is a hot new area. There's a lot of new products coming to market, and a lot of them are trying to, support the entire life cycle that we've described here. So it may not be a bad idea to evaluate those tool sets because they'll help you support all of the functionality you might ever need. But I would say first figure out what you do need before you start spending money and time on tools. But that's the consultant talking.
We do have another session that we'll continue the conversation on with Wayne here, everyone. And this is going to be on the creator side. So we've got a bunch of founders and creators on a roundtable talking about how they've created DataOps solutions and real life examples of how companies are using it. So we're going to be joined with Matthew Carroll from Immuta, with Christopher Berg from Data Kitchen, Ry Walker from Astronomer, Justin Borgman from Starburst, and myself from Unravel. So looking forward to that one as well. Wayne, thank you so much. This has been a great session.
It's been a pleasure.